Hey folks, welcome back to Precalculus. Today we're talking about Chapter 5, Section 2, and the unit circle. Okay, so it's going to help to have your unit circle handy as we kind of go through this. It's going to be a rather quick lesson because we've kind of front-loaded it, learning what the unit circle is and all the special angles and their ratios. So first thing we're being asked to do is evaluate the cosine, sine, and tangent of theta, given that theta is 2 pi thirds. So 2 pi thirds is an angle that's about roughly right there. If you look at your unit circle, that should be where you find it. Okay, and if you remember, the cosine of an angle is going to be the same as the x-coordinate on the unit circle. So the x-coordinate of that point right there is going to be -1/2. The sine of this angle of 2 pi thirds is going to be the y-coordinate of this point, which is going to be positive radical 3/2. And the definition of tangent is y over x or sine over cosine. So if we take a look here and we say, okay, the sine value was radical 3/2 and the cosine value was -1/2, my 2's will cancel out, leaving us with radical 3 over -1, which is negative radical 3 for a tangent value. Okay, moving right along, we're being asked to evaluate the cosine, sine, and tangent of -45 pi. So you probably noticed a little trend of like, here's 0, 1 pi, 2 pi, 3 pi, 4 pi, odd pi, even pi. And it's the same thing going backwards. -1 pi, -2 pi, -3 pi, -4 pi, negative odd pi, negative even pi. So -45 pi is going to be right there on the negative x-axis. So the cosine of that angle is going to be -1. The sine of that angle is going to be 0. And the tangent, like we just talked about, is going to be y over x, 0 over -1, which is 0. Okay, moving forward, you probably noticed that you have a graphic here of the entire unit circle. So what I'd like everybody to do right now is to go ahead and pause their screen, their video. So go ahead and pause your video, and I want you to fill out the entire unit circle with degrees in this slot for the angle, radians in this slot is a fraction bar, so just a little hint. It should look like this: pi over 6. Okay, the cosine, the sine, and the tangent for each angle. You can write the tangent just outside the coordinate if you'd like. Pause the video, go through, and fill in the entire circle. Okay, there you go. So right now you can go ahead and pause your video and check your unit circle to make sure it matches mine, make sure everything is all up perfect. If you find yourself copying it right now because you don't have anything filled in, then you might need a little bit more practice on the unit circle. But you should get to the point where you can generate this whole thing on your own. So pause the video, take a look at it, make sure it matches up. Okay, so let's keep moving. And let's talk a little bit more about the definition of trigonometric functions. So recall that the sine of any angle is the y-coordinate, okay? The y-coordinate over the hypotenuse, opposite of hypotenuse. The hypotenuse is 1 on the unit circle. The cosine of any coordinate is going to be the cosine of any angle is going to be the x-coordinate, and we just talked about tangent being y over x. Okay, now this function right here, cosecant, is the reciprocal of sine, so it's going to be 1 over y, or your y value flipped upside down. Secant is going to be the reciprocal of cosine, or your cosine value flipped upside down, and cotangent is going to be the reciprocal of tangent, or your tangent value flipped upside down. Okay, so now let's talk a little bit more about the properties of the quadrants and how they affect the trigonometric function, because you probably noticed that the unit circle looks very repetitive. Okay, so let's talk a little bit about, because the angles are all about the same in every single quadrant, let's talk a little bit about how the coordinates relate to each other. So to do that, I'm going to write sine, cosine, and tangent in each one of these quadrants, and I'm going to write cosecant, secant, and cotangent. They're reciprocals. Now let's talk about quadrant 1. In quadrant 1, the y-coordinate is always positive, so that means that the sine coordinate is always going to be positive. In quadrant 1, the x-coordinate is always positive, so the cosine is going to be positive. And by definition, tangent is y over x or sine over cosine, so a positive over positive is going to be a positive. And the reciprocal, 1 over a positive, is still going to be a positive. So let's go ahead and do quickly the other quadrants. I'm going to pause the video so I can fill them all in first. Okay, here we go. So in quadrant 2, the sine value or the y-coordinate is going to be positive as we're going up in quadrant 2, which means the reciprocal is going to be positive. Now we're going left, so the x-coordinate is going to be negative, and the reciprocal of a negative is negative. And y over x or sine over cosine, positive over negative, is going to be negative as well. Okay, so let's look at quadrant 3. The y-coordinate is going to be negative. The x-coordinate is going to be negative. It's going left and down. But a negative over a negative is positive. And the reciprocal of a positive is going to be positive. So now let's look at quadrant 4. The y-coordinate is going to be negative, which means its reciprocal will be negative. We're going right, so the x-coordinate is going to be positive, which means its reciprocal is going to be positive. And again, here we have a negative over a positive, which is going to make a negative tangent or cotangent value. Okay, so let's just do one example together. And it may be beneficial to flip over and use your unit circle, okay, unless you've got it memorized already, but you can use it for now. So 7 pi 6 is this angle right here on your unit circle. All right, so the sine of 7 pi 6, or the y-coordinate there, is going to be negative 1/2. And if you flip it, you're going to get negative 2. The cosine of 7 pi 6 is going to be negative radical 3 over 2. And if you flip it, you should get negative 2 over radical 3. Well, we can't have a radical in the denominator, so that's going to be negative 2 radical 3 over 3. The tangent value of 7 pi 6 is radical 3 over 3. So if you flip it, you get 3 over radical 3. Again, we can't have any radicals in the denominator, so we get 3 radical 3 over 3, and the 3's cancel out, leaving us with just radical 3. Awesome job, everybody. I know even though it's a quick video, it is a lot to take in. Please come to class with questions. Keep practicing that unit circle, and I look forward to helping you out.